Okay, so good morning everyone, and welcome you the another class of manufacturing technology on the CNC. So now this is the alphabet that we actually all the alphabets has some meaning in the CNC. Okay, if we consider A, B, C, all the things D, F, G, maximum all the alphabets have some meaning in CNC, but it is not always used. Okay, you have to remember only these few things of them. Okay, sometimes it is important. So now these are the steps from the drawing to the workpiece. This is our from our drawing to actually the part that you want to produce. So this part initially you have to have some drawing on that, and after that you, if you are the programmer, you have to read that drawing and understand that drawing also. After understanding, you have to program how the tool will move. Okay, so this is the main actually our concern, that for that reason we all the classes is organized, how the programming can be done in CNC. So before, this is the prerequisite. What is the prerequisite of your of doing your CNC programming? Prerequisite, you have to have some knowledge on the drawing. Okay, so if you do not have seen any drawing before, you will not understand what does it mean. So this is very important things: reading the drawing, then understand the drawing, then you have to program what is the tool movement. This is your part. Now this type of programming will fade into the MCU or machine control unit, and you will sit anywhere in the AC room, and the machine will cut the total things, entire thing you will observe in the monitor, because this is the computer numeric control. So there should be some computer and monitor, and this monitor you will only see that how the tool is moving, what will the part is being produced. Okay, so this you can see in anywhere in the place which is far away from the shop floor. So this is the input programming. You will just put the program in the MCU, and the manufacturing of the operation is in the shop floor thing, and this will cut the total. And if your program is right, then it will make as per your drawing, it will manufacture some part. So this is the advantage. Okay, so main very less. And if the one program you have calculated this type of products, thousands of products or lakhs of products you can manufacture within a day, as per the time requirement of your producing of job. So this is the advantage of CNC. One is the very time consuming. If you consider total time consuming is very much less compared to the conventional machining process, because human intervention is very low. If the human intervention is very low, then the accuracy level is increased, as well as the waste of the material is very much decreased. That means productivity of the total thing will be increased. Productivity will increase for the particular operation. So this is the main things that is the important or advantage of the CNC. Now these are the very important G codes. There are a lot of G codes and M codes are there, and this is called also preparatory code. Sometimes it is called preparatory code, and M is the for miscellaneous code. So sometimes this you have to remember these codes, because sometimes it is very much needed, and it will be not supplied in your questions paper. So you have to have remember other there is no such a shortcut. Okay, so, so G00 rapid traverse linear interpolation, for G01 circular interpolation. What is the interpolation mean? The tool will move linearly from one point to another point, and tool will move circularly. From it may be clockwise, it may be counterclockwise, like that. Dual is for the it is only applicable when the tool needs to be stopped for or pause for a certain duration of time. This G04 is important, and sometimes I have already told you for the peg drilling operation. So peg drilling, what is peg drilling operation? So if the aspect ratio of the drilling is very much high, aspect ratio, what is aspect ratio? That is L by D ratio. What is L, what is D? This is L is nothing but the length of the hole, and D is the diameter of the hole. So if length of the hole is very much high compared to the diameter, so for that reason, when the L by D ratio of the hole is very much high, so at that, in that case, in one pass you cannot drill that hole. So you have to have some after certain depth, If this is 10 millimeter, you will only give 2 millimeter a pass. Then five passes, or you will 10 millimeter you can drill. So after 2 millimeter, you can retract the tool. Otherwise you can stay the tool for a certain duration time with the code of G04. This is meaning of why this is important, dually why it is important, because at that time what will happen, it will happen, the chips will remove from the groove, and as well as the you will supply the coolant also. Then the tool will also cool at that time, because no cutting action will be done. So this is the main thing, otherwise tool may break, or the surface finish of the hole is not so good. So these are the reason why this is dual is given, and what is the peg drilling and all. This is actually only applicable for the drilling operation. Now G17 for the XY plane, before actually programming, you can give, if you have different plane operation, if you only taking the plane only one place, or you are making the program for the simple geometric components, then this is not important. But it is important when simultaneously two or three planes you are simultaneously cutting, or it is important somewhere. So for that reason we have to specify that G17 for XY plane, G18 for XZ plane, and G19 is the YZ plane. So now G20 and G21 is very much important. G20, some books is also written G70 and G71. G70 is for inch unit, and G70 is inch, and G71 is the metric unit. Like that, G20 or G20, you can write any from those. So G24 is the radius programming, only CNC lathe it is used. So some specific is also used. Return to the reference point. G20 it is sometimes used. G29 return to the reference point. G32 is the thread cycle. This is also applicable only for threading operation. G40 cutter compensation cancel, and this is cutter compensation left, cutter compensation right. So these three are obsolete nowadays, because MCU has already understood or already calculated the cutter compensation that I have told you. G43 tool length compensation, as like cutter compensation for the milling operation, it is actually for applicable for the milling operation, and tool length compensation is applicable for the drilling operation. So this is also for it is nowadays not actually used. Tool length compensation plus, tool length compensation minus, and tool length compensation cancel. So this is one can cycle G80. This is can cycle, and this is for a different application G81 to G89. This is the can cycle use. And what is the can cycle? Can cycle is nothing but when we will same types of steps we are going to give in the programming. Then instead of the every times we will write the step, and we will give some examples also on the can cycle. So G80 is the code for the cancel, and G80 to 89, this is different on the milling and drilling, boring, and depending on the different type of thing, we will actually G81 to G89 is the code we use. G81 is the can cycle we use for the drilling. Okay, so this is the thing. So can cycle will give some examples how the can cycle is operating when when it is needed. So these are the another things. G82 is the counter boring cycle. This is very much a particular applications nowadays. It is not actually used, and in your syllabus is also it is not in the syllabus. Counter boring default drilling cycle. G83 peg drilling cycle. G84 the can turning cycle. G90 and G91 is the very much important, and G92 is also very much important. Absolute zero shift. So absolute zero shift is the code when the I have already told there is a machine reference point, and after the machining operation, the it will go to the absolute zero shift. It is actually set by the manufacturer. G90, G91 is the absolute positioning, incremental positioning. I have already told you in the previous classes what is the meaning of absolute and what is the meaning of incremental coordinate systems. So these are the miscellaneous codes. So only the G codes. G codes is used only for the movement of the tool. How the movement will be done in the tool. And but it is not sufficient only, because you have to run the spindle, you have to run the coolant also. Sometimes it is flooded when the rough turning operation or rough operation is done. It is sometimes missed when the finishing operation can be done. So these are the case when you have to give some miscellaneous code also. So these are the codes you have to also remember. This course M00 is a program stop, M02 is the end of the program. So after the end of the program M02, you have to use program stop. You can use or you may not, because end of the program M02 and M30, end of the tape, these are the uh, main two codes which is used. And rewind nowadays it is not used. Previously I have already told it was NC, not CNC. They at that time punch tape is used instead of computer. Now the everything is computerized, and now the punch tape is not used. But initially this type of punch tape is used where some holes are there. So if these number of holes at a line, so only holes are there. Some lines has 10 holes, some lines has 2 holes, some lines has 3 holes, and this is meaning as a alphabet like Z01, Z02, and this is the thing. So when the computer was not in the place, NC was in the place. So that at that time this type of punch tape is used as like our tape recorder. And this is actually sometimes when it is starting operation, every tape is winded over here, and after finishing operation every tape is here. Now you need to rewind that tape before doing the next operation or next, or initially you want to start the job. So for that reason rewind operation is given, and this M30 was the code for the rewind operation. Now it is only used for the end of the programming for purpose. Okay, now rewind is obsolete. So M03 is the spindle start. You have to give M03 before starting the operation. Forwardly, if the spindle started counter clockwise, this is M03. M04 is the counterclockwise. Spindle stop. After the machining operation, you have to stop the spindle with the code M05. M06 is the tool change. After one operation, you have to, if you want to change the tool, then M06 is you have to give, and initially you have to give tool change because somewhere your tool is there and with some numbers, then M06 with some numbers you have to give before starting the operation. So M08 coolant on, before starting the operation you have to give M08, M09 coolant off. So before after finishing the operation you have to stop the M09, then coolant off, spindle off, and then a vice chuck and vice open is also important sometimes. And this is actually for holding the job. Vice is important. So before starting the operation you need to M10, you can write to hold the job, and after the finishing operation to take the job from the chuck you can open and close the vices. So this is only applicable for the CNC lathes. So these are the miscellaneous code you have to remember. And another is the absolute zero shift that I have already told you, that G90 code is the for absolute zero shift. This is the position machine will reference as part 0. So this is the thing. So when it will go, the programmer first sets command G90 to absolute zero shift, tells the MCU how far from the home zero position the coordinate system's origin is to be positioned. So it will be understood by you when I will give you the example. So this is the thing, the absolute zero shift is important for the CNC programming. So now this is the gauge height that I have already told you, that the cutter tool radius compensation is important for milling, and this setting of R plane or height compensation is important for the drilling purposes. So this is nothing but the height from the surface of the workpiece. This is the safe side, and this is generally 0.1 inch is given, or you can say 2.5 millimeter from above the highest surface of the workpiece it is given, which is known as the gauge height. This is important, and you will just read that one. And some manufacturers build a gauge height distance of 0.1 inch into the MCU, that is machine control unit. So these are the things which is very important. Sometimes gauge height for the drilling operation. Some cutter radius compensation, as it is also important because I have already told you that it allows the use of cutters that have been sharpened to a smaller diameter. Okay, sometimes permits the use of larger or smaller tool already in the machine storage matrix, allows backing the tool away when roughing cuts are required due to the excessive material present, and then permits compensation for the unexpected tool or part deflection that I will show in the next slide if the deflection is constant throughout the programming path. So this is the thing. So that's why cutter compensation is needed. So not cutter compensation is nothing but the this is the actually tool path. By the cutter compensation you will make the actually the tool path. So if the actual part is the highlighted black portion is the actual part you want to manufacture, then you have to remember what is your tool diameter. If this is 1 inch your tool diameter, then your tool path will be offset of the zero point 0.5 inch. Okay, so if it is sometimes you zero point 0.5 you will give 0.7 you will consider, then undersized card or this type of excess material will remain there. And if we will give you instead of 0 0.5 we will give 1.25 oversized milling cutter, then this type of excess material you may cut. So for that reason this is important, but nowadays it is not so important because you will already with the M06 comments you will already mention where your tool with some number like G02. M06 is the tool change comment, G02 is the tool number, and this is with the diameter you will already mention here the diameter of the tool, and with that it will automatically calculated the coordinate point. So this is the thing. So cutter radius compensation is sometimes needed, and this is the sequence of the operation of the G code time code, and this first time is the sequence number. So this is important sometimes because if you not give the sequence number, if some kind of error will occur in the programming, then it will be not understood by the machine or machine control unit. Then where in which line the actual error is there. So for that reason you have to mention some sequence number with the any kind of code you mention. So in after N001 always we will not give N002. We will sometimes we will give 005, then 010, like that. Why it is so? Because we must try to give some gap in between those, because if we want to incorporate, because if you N002 after that if you give N002, so if some lines you want to incorporate after the machining or after the doing the total programming, then you cannot incorporate. That's why some gap is needed. So this is the things you have to remember. And then the proprietary function G01, that is the actually code you want to tell the tool where to go. These are the dimension where to go. Then the miscellaneous function like tool change or any kind of vice open, vice close, coolant on, coolant off. These are the things of the miscellaneous code you have to mention after the preparatory functions. So with this, I will conclude this session and we will see you in the next class. Thank you.